Okay, hello everybody, and this is Mr. Frazier again, and we are doing 8-4, which deals with two vocab words. Now, please remember, this is vocabulary. We've already done all the math to be able to do this. Okay, we've done sine, cosine, tangent, special right triangles. So finding the angle measurements is not the big deal here. Here is understanding what the angles are, okay, first of all, and then understanding where we put measurements. Okay, this is angles of elevation and angles of depression. These are two vocab words. So first of all, you got to know where they're located. And then second of all, you need to understand that the algebra or the trig that's used, which would be sine, cosine, tangent, is the same as all the other problems. But in these, you actually have to set the problems up correctly. All right, so let's just look, and I'm going to start with a generalization. I've told you or tried to get you in the habit of drawing the same triangle every time. So I draw this as a right triangle, okay? And the key to this is drawing the same right triangle every time, okay? And I'm going to tell you that no matter what they give you, no matter what one they give you, no matter if they give you angle of elevation or angle of depression, you will always put that measurement here. Now, I'm going to get to explaining why in just a second. But understanding that when we're solving, this is just for when they want you to solve. If they want you to identify, you'll see where the difference is. But for right now, if they want you to solve for something, x, angle, whatever it may be, you're always going to put the angle of elevation or the angle of depression in this same spot. And then you're going to read the problem, and if it says the height, you put it here. If it says a shadow, you put it on the ground. You should know where shadows go. They're on the ground. They're not floating in the air. We're not Peter Pan. Okay, so it's important that you understand what those things are, because they're going to give it to you in words, and you have to put the numbers in an appropriate spot. If they say horizontal, it's down here. If they say vertical, it's here. If they say diagonal, it's here. Okay, so you have to make sure that you understand the words so that you can understand where to put numbers and variables. All right, so that's the first thing, setting up a solution of a problem. If you're identifying it, I'll explain it to you like this. An angle of elevation and an angle of depression have to deal with line of sight. So in other words, if a person's standing here, okay, that's their eye level. When they look up, and I'm going to draw my makeshift bird, okay? When they look up, this is called an angle of elevation. Now here's the catch. The bird's line of sight is here. So for example, the bird is looking here. It's flying along in a straight line, hopefully. We're just pretending, okay? Now notice, this line and this line are what? Parallel, correct. So if the bird is looking this way, when the bird looks down, this is the angle of depression. Okay, so where they're located is in two different spots, but their measurements in the right triangle could go in the same place. Can anybody tell me why I can make these measurements the same? What do you see? Correct. Hopefully you said alternate interior angles. And we know that alternate interior angles are congruent, which means an angle of elevation is equal to the angle of depression. So if they give you the angle of depression, you can put it in this spot because the angle of elevation is supposed to be the exact same measurement. That's why it won't matter whether it's an elevation or depression, because you can always put it in the same spot of your right triangle. Physically, is it the same? No. Numerically, it is. So for example, if I wanted to do the angle of depression, I would have to extend a line out here, and the angle of depression would be here. Okay? The angle of elevation is here. So you have to remember that their locations are different, but their measurements are the same. That's why when you're going to solve, you can always stick the angle of elevation and depression in the same corner. If they ask you to find it or tell me what kind of angle it is, then you have to know that you're looking for the parallel lines, and this would be looking down and this would be looking up. But they're going to be alternate interior angles. This is nothing. Okay, this angle over here is the third angle inside the triangle. That's about it. It's not an angle of elevation or depression. Just because it's on top doesn't make it depression. It's the parallel line that makes the angle of depression. Okay, just like the parallel line here. So paying attention to the words is what makes this part hard. Okay, so I'm going to give you a problem here. So get ready, take out your pen or pencil and a calculator. And I'm going to read you a problem, and you're going to attempt it. So you're at the top of a cliff, and at the top of the cliff, it is 300 feet from the water. And there's a boat on the water. The angle of elevation, the angle of depression is 58 degrees. Find how far the boat is from the cliff. Okay, so we'll try it again. You have a cliff, and before we even started, hopefully you went ahead and you said I have a cliff, and you drew your right triangle because we're going to draw the same right triangle. And you know the cliff is 300 feet. So hopefully you understand cliffs drop. So this has to be the 300 feet. Here's my water. Here's the boat. So drawing pictures will help tremendously. I need to know how far it is from the boat to the cliff. So the boat's over here, cliff's over here. Boat to cliff. Okay? Now, if I said, I'm going to throw a line down to the boat, how long is the line? Then I'd be talking about this. But I'm talking about how far is it from the boat to the cliff. And I said the angle of depression is 58 degrees. Now, some of you are going to want to put 58 here. No. The measurement for any of these triangles, whether they give you depression or elevation, will always go here, 58 degrees. Why? Because the angle of elevation is supposed to be equal to the angle of depression. All right? So now I would use sine, cosine, or tangent to figure this out. Well, let's see. We put our finger here and name the sides. I have the opposite over the adjacent, which means I use what? Correct. I use tangent of 58 degrees equals 300 over x. And then algebra, how do I solve that? Remember the shortcut, if x is in the denominator, I just switch. So I have x equals 300 divided by the tangent of 58. And this is all I have to see on your paper. I have to see the original setup, and I have to see what you did algebraically. The rest is all done on the calculator. So then we put x equals, and hopefully you put it in your calculator correctly. I'll show you how to do this again. So you would go, what is 300 divided by the tangent of 58? You hit equals, and you get, it is 187. And I'm going to use approximate. Why? Because there's a decimal answer. So x is approximately 187 feet from here to here. All right? So that is angles of elevation and angles of depression. Remember, one is visual location. They're in different spots, but they're alternate interior angles. So that means when we do the math, we can always put it here. So when you're drawing the picture, always put it here to do the math. If they're asking to visually identify it, they're going to have different things on the picture, and you're going to have to know when I look up, it's an elevation, when I look down, it's depression. But they're alternate interior angles. All right? So you have location and you have the math. Now, the sine, cosine, and tangent and all the rest of the stuff remain the same. I wish you luck. Good working.